We've got 2 area problems we're going to do for a bell ringer, and then a little Pythagorean theorem problem just to get us warmed up. So we want to find a circle with a diameter that's 11. Well, we don't want the diameter, right? We want the radius. So we got to take this, we got to cut it in half, right? Yeah. So let's do that. We got 11, 5.5. 5 by 2 is 5.5. Very good. Well done. So now we've got the radius. Now we're just going to do pi r squared. So 5.5 squared. I should probably get a calculator, huh? 30.25. Thank you. That saved me from having to do it. Appreciate you. So square r and put a pi on it, right? So 30.25. Yeah. So pi times 5.5 squared. Well, 5.5 is 30.25 pi. So our answer here, 30.25 pi. Notice I'm just leaving it in terms of pi. Sometimes they're gonna ask you round it to something. Leave it in terms of pi. When in doubt, read the directions. But if the directions don't tell you, just leave it in terms of pi. It's less work for you, right? Less numbers to write out, less things to punch into the calculator. Let laziness guide you when in doubt of how to do it. Leave your radicals alone, leave your pi's alone, and leave it in exact form because it's less work. It really is, I promise. All right. A square with a side length of 7. Well, remember, we want to find the area of a square. It's just side times side, right? Both of those things are 7. So 7 times 7. You get 49, right? So here the answer is 49. For this last one, remember Pythagorean Theorem, a squared plus b squared equals c squared. Leg squared plus leg squared equals hypotenuse squared. Be careful. One of the most common mistakes I see with Pythagorean Theorem problems is that you just put x in any old spot. This is the hypotenuse, right? 12. So 12 better be the one by itself. And then you've got the 2 legs. I have so many people who will put x over here, rain or shine, no matter where x is supposed to be. Pay attention because it does matter, okay? So let's do this. 7 squared is 49. 12 squared is 144. And then subtract the 49 over. That ends up being like what, 95? 95, excellent. Thank you. I appreciate your reassurance. And then 95 we know is not a perfect square, right? And in fact, it's like 5 times 19? 5 times 20 is 100.
Yeah, 5
times 19? Yeah, okay, good. My brain is in fact working this morning. The coffee has already kicked in. I'm running at 3 gigahertz or whatever it is. All right, so I know that 95 is not going to come out nice, and I know it's not even going to break down, right? There's no perfect square factors of it, so I'm just going to leave it. Like I said, when in doubt, it's okay to be a little bit lazy. Just leave it as radical 95. It doesn't break down. It doesn't simplify. And if you try and take the square root, it comes out to be 9 point some ugliness. So why do more than that, right? Unless they specifically tell you to do that, don't, right? So, like, it's not like I'm saying, hey, how many chickens is that? In which case you need to say 9 and then some drumsticks, right? But like here, we don't have to do that. Just leave it alone. Let it be its own little radical 95 self. Let it vibe on its own, okay? Okay, questions about this? We feeling all right? Especially with that Pythagorean theorem thing, it is going to come up in a couple places because we're working on pyramids today, volume of a pyramid. The one thing I'll say about the volume of a pyramid is that it's a lot easier than the surface area was. It's almost as easy as what we did on Monday, which was the volume of a prism, right? Because the area of the base times the height for the volume of a prism, almost as easy, because now it's the area of the base times the height divided by 3. 1/3 area of the base times the height. I used to do this little demonstration back when I had manipulatives that weren't all stored away and I had a full class and I could do it without being a COVID problem. But like I had a graduated cylinder and a cone, and both of them had the same base and the same height. And I would take the cone, fill it up with water, pour it into the cylinder, it would go exactly 1/3 of the way up. And there's going to be a picture in there that's almost good enough that you'll be able to see, but like it was always so much cooler when I could actually physically stand in class with a thing of water and have it spilling everywhere, but still it was entertaining, it was dynamic, and I can't do it this year, but there's a picture, sort of. But yeah, so it's kind of hard to see in person. I'm going to make it bigger. 1/3 area of the base times the height of the pyramid. And we are talking about the height from floor to ceiling, not the slant height. And that's very important. Surface area uses the slant height. Volume uses just the OG height, right? The altitude from the vertex at the top straight down. Now, we talked a little bit on Monday about what happens with the ones that are leaning to the side, right? Same thing here. Because of Cavalari's principle, it doesn't matter if they're leaning or standing straight up. It still behooves you just take this picture and redraw it like it's normal and not leaning to the side for some reason, right? These two, if they have the same base and they have the same height, have the same volume. So you don't have to worry about some weird thing happening. You just need your straight up and down height. All right, has everybody got this that needs it? All right, everybody out there in the matrix, we doing okay? Cool. So let's jump straight in. We've got the entrance to the Louvre Museum in Paris. Anybody ever seen that? You've seen it. You haven't? Here, I'll pull it up. This is actually really cool. It's like this decorated glass pyramid thing. This is the outside of the Louvre. And at night they light it up and it's really pretty. But yeah, it's really, really pretty at night. I've never gotten to go to Paris, so I've never seen this in person either, but one of these days I'm going to go. All right, let's do this problem. The entrance to the Louvre Museum in Paris is a square pyramid with a height of 21.64 meters. And we want to know the approximate volume of the pyramid itself. We know that the length of the side, this is also given information. I had to cut out the picture that was in the book because it had all the work there too, and I wanted to do it for you. But the length of the side of one of the base on the base of the Louvre is 36.4 meters. So let's find the area of the base. Let's find the height, and then we'll do 1/3 base times height to get the volume, right? So area of the base is just side times side, 36.4 times 36.4, which is 36.4
1324.96.
Thank you. And then the height is just right here. We just read it off. 21.64. So now from here, all we have to do is just multiply those two and divide by 3, right? It's going to be ugly, and that's okay. In general, if it comes out ugly on the calculator and you're doing it like this, you can leave it as a fraction. Just multiply these two and then put it over 3 if it doesn't come out nice. But here they want the approximate value anyway. That we don't care. We just want to round it to 4 decimal places because they don't tell us, right? So when we do this, 1/3 of this times this, right? We just get and it goes off 3, 3, something, 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 something. Probably 3 repeating after that. But we only round to the nearest 4 decimal places anyway, and our units are meters cubed. So there we go. So once again, same thing like what we did on Monday, right? First, find the area of the base. Then identify the height. Multiply those together, and in this case, just divide by 3 and get what your answer is, okay? Here's your turn. It's a sports arena. They actually give us all the things here in the words this time. It's a sports arena shaped like a pyramid. And we're going with a, they tell you the base area is this, and they tell you the height is that, and we want to know the approximate volume. All right, so let's do this, right? Pretty simple, and the numbers come out really pretty, which is great. It's like it was constructed to do that. So again, you're just finding the area of the base. You're finding the height. Hey, they give you the area of the base.
And they give you that?
I know. It's like this is like the easiest problem we've ever done. It's just like, hey, put the numbers down on the paper, right? And then just do that times that divided by 3. Now, I don't know about you, but I don't want to have to like do a bunch of stuff. I'm just going to divide that by 3 right now and get 100,000, right? And when you divide by just 1 followed by a bunch of zeros, or multiply by with 1 and then a bunch of zeros, all you have to do is take all those zeros, put them on the end of the number, right? So this is
32 million.
Yes. 32,100,000. I don't know why they're talking about the approximate area like this isn't the exact area. Or volume, right? Feet cubed. That's a lot of feet. Same idea, right? Now, they don't just give it to you, but it's a square pyramid. It tells you the base edges, and it tells you the slant height. So this is the part where we have to, like, do some stuff. Oh, no, right? Area of the base, and we want the height, not the slant height. So, first of all, a couple things that might help us is to sort of visualize this a little bit. So we have the slant height, but we want the actual height, right? So we want to figure out what these things on the inside are. We want the height, but we have the slant height. Well, okay, we know that the whole edge here is 40. So we just want half the edge, right? So this is just going to be 20, right? So now let's Pythagoras our way through. X squared plus 20 squared equals 25 squared. This is going to come out nice and even, though. I'm really excited. All right. So 25 squared. That's 625. 20 squared is 400. Subtract that over. End up with x squared equals 225. And I'm going about this like the long way. For y'all, it's going to take 2 seconds to do, right? Square root that, I get 15. Hey, that was easy. And then the area of the base, well, 40 by 40, 1600. And it's going to come out nice and even again. And that's exciting because it's 5 is a multiple of 3. That's so great. So if you want to do this in your head, you can be like, well, 15 divided by 3 is 5. Then 5 times 1600 is
8,000.
Yes, sir, 8,000. Ta-da! But you know, calculator's fine too. Just right now I've got the brain juices flowing. I want to ride the wave. Same idea as what we just did in the previous problem. They give you a square pyramid. They tell you what the edges of the base are, and they tell you what the slant height is. Go ahead, figure that out. So with this one, again, you're trying to find the base and the height. The base, they give you the edges of the square. They give you the sides of the square is 24. So you're just going to square that to get the area of the square. The height, they don't give you the height. They give you the slant height. So just like in the previous problem, they give you that the slant height is 13, but we want the regular height. And since this whole thing is 24, the part that we actually are looking at for half of that is 12. The slant height's 13. And then we're going to use the Pythagorean Theorem. Then we can square those things. That's plus, let's try that again, 144 equals 169. Subtract. We get 25, square root. We get 5. And then, now we can finish our problem. 1/3 area of the base times the height. And we end up with 960 exactly for our final answer. Our units are meters cubed. So we're going to do a bunch more of these now. We're going to do like 4 more, but now they're all going to be circles for the base. So the book decides that they have to like, yeah, here's where the picture is. These 3 cones of rice will fit the cylinder that has the same base and the same height. So imagine that, but in real life. So much cooler, right? And again, they're going to try and give you this extra little formula. 1/3 pi r squared h. But pi r squared is the area of the base, right? This is still 1/3 base height. It's still the same thing. It's still the exact same thing. If you want to use the special formula because you want to, great, awesome. No worries. It'll get you the exact same answer. Same thing. So now time for 4 more problems. It's just now it's a cone. It's 12 feet high. And they tell us that the base diameter is 14. Right? Now let's find the volume. It's a circle. So we need the radius, which is going to have to be 7, right? 7 squared pi. And then they give you the height straight away. Hey, that's great. So now we're going to do 1/3 area of the base times the height. Now they tell us what's the approximate volume, and they don't give us any sort of direction on that. So in a situation like this, I'm always going to give you specific direction. I will never say just find the approximate. There will always be, hey, you need to round this to so many decimal places. So here, since they don't tell you, and I don't want to do with that. Let's just leave it in terms of pi, okay? So like here, 12 divided by 3, we get 4, right? 49 times 4?
196.
196. Yes, 196. 49 times 4 is the same as 14 squared. And our units are feet. So again, it's the same thing. We found the area of the base, we found the height, we multiplied those and divided by 3. Same exact problem. Now they're just telling you, hey, take the height and the diameter and cut them in two, and then do the problem again. So like they didn't provide the OG info. So here's the OG info we had from the last problem. In my opinion, what makes this problem difficult is that they were being difficult about giving you specific information. So the OG info is that the original height was 12, the original diameter was 4. So for this problem, the height equals 6 and the diameter equals 7. So be careful, because that does mean that you have to cut that in half again. Right? We get so the area of the base, when we square 3.5, or you can just leave it as 7/2. That's what I did. I would rather just rather leave it like that. But it comes out to like 13 something, I think. And then the height is 6. So now all you have to do is 1/3 times and you can just throw that in the calculator and you round and you get 77. 77 fortissimo, because I just wrote 2 F's in a row. Right. Now it's an oblique cone. Does it matter that it's leaning to the side? No. You have the diameter, you have the height. So just be not afraid. So the radius is 15. So the area of the base is going to be 15 squared pi. The height's 25. So that's 25. And they say give your answer in terms of pi and also round it to the nearest cubic foot. Okay, so 225 divided by 3, I think is 75. Still a few sparks left. Pi that's 25. Just going to save myself embarrassment. Oh, turn on. See, can't escape it. So the exact answer should be 1875 pi feet cubed. And then they say round it to the nearest foot. So take 1875 in the calculator times the pi button. Nearest cubic foot, we end up with 5,890 feet cubed, approximately. These two represent the same quantity pretty much, right? All right, anyway, so here's your very own oblique cone. Notice, if you will, that the height and the slant height in this case happen to be the same. That doesn't matter, but they gave you the height, right? So go to town. So once again, we're just trying to find the area of the base, and we're trying to find the height. Don't be afraid of the fact that it's leaning to the side. They give us the height is 12. The radius is 6, so we can just square the radius pi. 6 squared is 36. And then all we're going to do is 1/3 base times height. Third of 36 is 12. So we end up with, when we multiply everything together to get our exact answer in terms of pi, we get 144 pi. Then all we do is take 144 times pi in the calculator, and we get 452. These are all meters cubed. 452 meters cubed. So here's our two answers, because they asked for in terms of pi and rounded to the nearest cubic meter.